Okay, in this problem I'm going to show you how to solve expression that involves a lot of exponent properties. So let's take a look at our problem here. Okay, so here we have 3x to the negative 2, y to the fourth, z to the negative fourth, divided by 2x cubed, y to the negative 3, z to the negative 4. And we're going to raise all that to the fourth power. So what I'm going to do is I'm going to take the fractional portion and raise it to the fourth power. So notice I did that here, and then everything else I'm going to separate it, and I'm going to raise everything else to the fourth power. But what I'm going to do here is I'm going to use my properties of exponents and rewrite x to the negative 2 divided by x to the third power. When you divide like bases with exponents, you subtract the numerator exponent from the, you take the numerator exponent minus the denominator exponent. So x to the minus 2 divided by x cubed is x to the minus 2 minus 3. And then y to the fourth divided by y to the minus 3 would be y to the 4 minus negative 3. And then z to the negative 4 divided by z to the negative 4 would be z to the negative 4 minus negative 4. Now obviously you have to be careful with your signs here. Minus 2 minus 3 is negative 5. So this would be x to the negative fifth. 4 minus negative 3 is the same as 4 plus 3. So that's going to give you y to the seventh. And then minus 4 minus negative 4 is minus 4 plus 4, which is 0. So you're going to get z to the 0 power. With the coefficients here, I just raised the 3 to the fourth power and the 2 to the fourth power. And then remember, all of this over here is still raised to the fourth power. Now, the next step, I'm going to go ahead and figure out what's 3 to the fourth power is. That's 3 times 3 times 3 times 3, which is 81. And then the bottom is 2 times 2 times 2 times 2, which is 16. And if you're allowed to use the calculator, you can just do it that way. Okay, now x to the negative 5 is the same as 1 over x to the positive 5. So I can move the x term to the bottom as long as I change my exponent to positive. I have y to the seventh that stays in the numerator, and then z to the 0 is just 1. Okay, so we know that 1's not going to affect anything. We don't even have to write it if you don't want to. Okay, now, so I've got 81 over 16 here, and now I've got to raise y to the seventh over x to the fifth to the fourth power. Well, if you do that, the property says if you have a fraction, you can raise the numerator to this power as well as raise the denominator to this power. But when you raise a power to a power, you actually multiply the powers. So y to the 7th raised to the 4th would be y to the 7 times 4, which is y to the 20th. And then x to the 5th raised to the 4 would be x to the 5 times 4, which is x to the 20th. And now we can put all this together and write it as a single fraction, where in the numerator I have 81y to the 28th, and in the denominator I have 16x to the 20th. And that's how you simplify expressions. Now, I'm assuming that you can review your properties of exponents here in order to follow the steps that I used in this problem. I'm also going to do an example involving rational exponents and radicals, but before I do, let me show you a couple of properties. Anytime you have a base like x raised to the 1 over n power, that's equal to the nth root of x. So for example, if you had 8 to the 1/3 power, that would be the same as the cube root of 8. I'm sorry, I put x there. I meant to put 8. Okay, so that should be an 8. Alright, and if you have x to the m over n, then that can be thought of two ways. That's either that you can think of it as the nth root of x, then raised to the m power, or you could raise x to the m power, then take the nth root. Generally, it's easier to take the root first and then raise it to the power. So for example, if you had 125 raised to the 2/3 power, you could think of that as the cube root of 125 squared, or you could square 125 and then take the cube root. Obviously, it would be easier to take the cube root of 125 because the cube root of 125 is 5, and then 5 squared would be 25, whereas here you'd have to take the cube root of a pretty large number to get the cube root of 125 squared. Okay, so now that we know how to write radicals as rational exponents, here we have the cube root of x to the fifth times the fifth root of x squared divided by the fourth root of x cubed. Well, the first thing we want to do is write these as rational exponents. So based on this property over here, the numerator is the power and the denominator is the root. So I can write this as x to a fraction where the numerator is the power 5 and the denominator is the root 3. And then the same thing here, except here the numerator would be 2 and the denominator would be 5. And then on the bottom, the numerator would be 3 and the denominator would be 4. Well, now I can use my properties of exponents, because if I multiply these together, you're just going to add these two fractions together, 5/3 plus 2/5. But what you're going to need is you're going to need a common denominator to add these. So since 3 and 5 both go into 15, I can write 5 over 3 as 25 over 15. Just multiply the top and bottom by 5. And then 2 over 5 can be written as 6 over 15. Just multiply the top and bottom by 3. Okay, and we'll deal with the denominator later. Okay, so this is x to the 31 over 15. If you add those together, you get x to the 31 over 15. Well, now I have x to a power divided by x to another power. So when you divide bases, you subtract exponents. So I'd have x to the 31/15 minus 3/4. Well, 15 and 4 both go into 60, so I can use 60 as the common denominator of these two fractions. So if I multiply 31 over 15 by 4 over 4, I'll get 124 over 60. And if I multiply 3 over 4 by 15 over 15, I get 45 over 60. And so I have x raised to the 124 over 60 minus 45 over 60, and that gives me x to the 79 over 60. So that's how you simplify radicals with rational exponents. And that completes this video on exponents and radicals.